Okay, hello everyone. Today for the assignment 2 for CHM5901 research design, we will be discussing on site 4 greener public transport through biodiesel and bioethanol. So we will analyze the cost of producing biodiesel and bioethanol to be used in Midsummer's small fleet of 42 buses, and also recommend which biofuel is most suitable to the company. So here we will be discussing about the positive and negative aspects of using biofuels, the reaction mechanisms for the production of bioethanol and biodiesel, and analyze the feasibility of using the biofuels against the use of petroleum fuels, and also suggest a waste management program for the project, including the handling of all the byproducts. So first I will talk about the positive aspects of biofuels. The first one will be maintenance cost. It is cleaner and produce lower carbon emissions for the biofuel. It also aids in reducing greenhouse gases and combat the global warming. So the second one will be the sourcing. Because of the biofuel can be made from vast variety of materials, it's easier and cheaper to source the biofuels, and especially when it is produced in larger quantities. The third point is renewability. Biomass used for biofuel is renewable resources. So most sources utilized for biofuel production can be generated within weeks. And the last point is the carbon equality, where the plants absorb an equal amount of carbon as to what the bios can emit, so there will be no extra carbon released to the environment. Okay, next will be the negative aspects of biofuel. For the long-term cost, it has a long-term cost because while maintenance cost of biofuel can be lower, the production cost remains high, and converting to long-term operations will be much more expensive. Next is the biofuel monoculture. The major problem of the biofuel mass utilization is the lack of plant genetic diversity, because you always plant the same kind of plant. So crop rotation is vital for farmers and the environment, which we don't get when we are producing biofuel. Next is the fertilizer use. Fertilizer is very harmful to the land and the surrounding environment, animals, and people if the fertilizer is rich in phosphorus and nitrogen. And the last point is pollution and water use, because of the biofuel crop production that requires large amount of both water and oil resources. So I'll continue with biodiesel. Biodiesel is a form of diesel fuel derived from plants or animals consisting of long-chain fatty acid ester. It is compatible with existing diesel engines and distribution infrastructure. Usually, it is blended with petrol diesel, typically to less than 10%, since most engines cannot run on pure biodiesel without modification. So the biodiesel blends can also be used as heating oil. In 2009, biodiesel production was using soybean was 700 million gallons, with a production capacity of 1.83 billion gallons in the US. So moving on the reaction mechanism for production of biodiesel. The trans-esterification process consists of 4 principal steps. Firstly, pre-treatment of soybean feedstock to remove the components that will be detrimental to subsequent processing steps. Then the trans-esterification takes place where the pre-treated triglycerides are reacted with methanol to form the raw methyl ester and glycerol. There are 2 basic steps. First, the reaction process, followed by the separation of the methyl ester and glycerol streams. So in most technologies, these 2 steps are undertaken twice to push the trans-esterification closer to completion by reducing the concentration of glycerol in the second stage. So the reaction is also pushed closer to completion by using an excess of methanol. Catalyst used here is sodium hydroxide, and glycerol carried from the trans-esterification process take place. So methanol removed is recycled to the trans-esterification process. Glycerol purification also takes place by removing methanol for recycling to the process. Further impurities such as sodium hydroxide, plant fat and methyl ester are carried in the glycerol and may be removed to produce a higher grade of glycerol if the economics dictate. So that's all for biodiesel part. Next, I'll pass to Kirtana to explain on the biodiesel. Sorry, bioethanol.
So the next most common biofuel produced is bioethanol. So bioethanol is a clear, colorless, oxygenated liquid containing 35% oxygen, mainly produced by the sugar fermentation process. So bioethanol produced globally in 2018 was 110 billion liters and is expected to increase to 140 billion liters in 2022 with compound annual growth rate of 7.6%. So US uses corn as the feedstock to produce bioethanol and obtained a production capacity of approximately 57.7 billion liters. Brazil produces bioethanol from sugarcane and had a total production capacity of approximately 27.6 billion liters in 2016 respectively. So the most common blend used is 10% bioethanol and 90% gasoline. So just to add on to the advantages of biofuel discussed earlier, other positive aspects of bioethanol includes it has high octane rating, resulting to increased efficiency of energy and performance. And apart from that, bioethanol also has low boiling point, broad flammability, high compression ratio, and heat of vaporization. Besides that, it also reduces burning time. So the disadvantages of bioethanol is it possesses low volumetric density, meaning that more volume of bioethanol per kilometer, which is up to 50%, will be consumed compared to conventional gasoline. So besides that, the use of bioethanol in engines might also require frequent replacing of engine parts, as bioethanol has the capacity to degrade some elastomers and cause corrosion of metals. So next, I'll move on to the next slide. Okay, I'll move on to the reaction mechanism for the production of bioethanol. So it basically involves 5 main stages. So the first stage is physical pre-treatment, which is dry milling of corn kernel to produce basically to produce flour, and onto the second stage, which is the liquefaction, addition of water to the mash, and cooking of the mash at high temperature to soften the starch grains to form soft and spongy grains. So the next stage will be the enzyme catalyzed hydrolysis, or also known as saccharification, in which the starch is converted to glucose by alpha amylase and glucoamylase enzymes. The fourth stage is fermentation, where the glucose produced earlier is converted to ethanol by gluconeogenic enzymes produced by Saccharomyces cerevisiae yeast, and the byproduct is carbon dioxide. So finally, in the ethanol recovery step, the fermentation broth, which is about 5 to 10%, enters the pre-concentrated distillation column, where the ethanol concentration increases up to 92 to 94%. And next, it moves on to the extractive distillation column, where it is further dehydrated and ethanol concentration increases up to 99.9%. And finally, the ethanol is recovered in the solvent recovery column. So that's all from me. I'll pass on to Regina.
Okay, in order to assess the feasibility of using the biofuels against petroleum fuels, there are a few aspects need to be considered. The first one is the energy production. The amount of energy each fuel return is different. Soybean biodiesel returns 93% more energy than is used to produce it. Meanwhile, corn ethanol provides only 25% energy. So productions of corn ethanol is energy efficient in that it yields 34% more energy. This is based on the study done by Shapori and Wang, 2002. For soy biodiesel, the 1998 USDA study found that these types of biodiesel yielded 3.2 times fossil energy needed to produce the fuel. Next, we'll go to carbon emissions. Okay. Gasoline and diesel fuel consumption in the US transportation sector resulted in the emissions of about 1,373 million metric tons of carbon dioxide, which is equal to 84% of total US transportation sector carbon dioxide emissions. And in contrast to petroleum fuel, biofuels do not release as much carbon as fossil fuels do, and because of this, there are fewer harmful emissions out of biofuels. Bioethanol and biodiesels are both carbon neutral, in which the plants that act as a feedstock absorb carbon dioxide as they grow. So the absorption replaces the carbon dioxide that forms during the productions and burning. Corn ethanol releases 39% lower carbon than gasoline. Meanwhile, soybean biodiesel produces only 41% less GHG emissions than diesel fuel. Lastly is the production yield. Average corn yield nationally was 167.5 bushels per acre in 2015. So ethanol yield per acre would be 462 gallons from 165 bushels of corn. For soybeans, it yields 1.5 gallons of biodiesels from 1 bushel. So in US, using all of the soybean stocks for biodiesels could produce 5.1 billion gallons of biofuel. Next will be waste management and costs.
So, waste stream developed for biodiesel is glycerin as a byproduct, and methanol and sodium hydroxide will be recycled and used back. So first, I would like to talk about glycerin. For every pound of biodiesel produced, 10 pounds of glycerin is produced by as a byproduct. And the critical part in it is it is impure, contaminated with unreacted soybean oil and methanol and sodium hydroxide. So further purification required to make it as a valuable product. And the market value for crude glycerin price is $2.5 per pound, which is very cheap. So in order to increase the selling price of glycerin, further purification steps required so that the selling price will be higher and the production cost will be reduced. Next option available for glycerin is used as livestock feed for pigs, where there is a place they use to feed pigs, and the reason behind that is metabolized to digestible energy ratio of glycerol is similar to corn or soybean oil. The last option is thermochemical conversion, where glycerin can be converted to valuable product thermochemically, such as propylene glycol and acetol. One more waste generated from biodiesel is wastewater, where water used to wash the biodiesel, to purify the biodiesel, and the water get contaminated. This water needs to be treated before releasing to environment. And one of the options, so every 1 gallon biodiesel produced required 1 gallon of water to purify it. So one of the options available to treat the water is acid treatment, where only 0.05 gallon to 0.1 gallon water required to produce 1 gallon of biodiesel, which means 92.5% is recycled, can be used back. And another option available is farm irrigation, where this wastewater is returned to the soil as a fertilizer, normally used for the small scale producer. Next, I'll move on to bioethanol waste stream. So this is the flow diagram of the bioethanol waste stream, where we can see the major compound produced as a waste stream is the tillage. Tillage mostly contain the husk from corn and etc. So this thing can be treated as for every 100 gram of corn used, 34.4 ethanol and 31.6 tillage is produced, which means 1/3 of raw material is produced as a waste stream. So this waste stream can be converted to DDGS, known as distilled dried grain with solubles. It contains high protein and high phosphorus, suitable for animal feed. So next is the carbon dioxide, also generated as a waste stream. This carbon dioxide contains a very high in purity. So only few purification steps required to make it a market product, which is dehydration and compression. So one of the questions raised from this is our concern is to reduce carbon dioxide gases, but still this process produce carbon dioxide can be reasoned with the limited stream and its negligible component in terms of total carbon dioxide emission. So finally, I'll move to major costs involved in biofuels. So from these studies, we finalized that biodiesel is much more suitable biofuel. So from this chart, I'll just highlight the major costs involved. Raw material, $17,507 per year, and the depreciation cost, $21,329 per year. Next slide, please. So the gross cost of production is 20 million US dollar per year. Total production of 10 times of 10 to power of 6 gallon, which means 0.527 US dollar per liter. So as I mentioned just now, the raw material cost is the major cost involved in the production of biodiesel, where it possesses 92% of total percentage from the total raw material cost and 87% from the total production cost. So one of the way to improve in this section is look for alternative oil, which is rapeseed oil and palm oil. Rapeseed oil is easily available in Europe country, palm oil in Asian country. Currently, the soybean oil produce 70.13 gallon per acre, rapeseed oil 127 gallon per acre, and palm oil 635 gallon per acre. So we can see that palm oil has the upper hand compared to the other tools, but the challenge will be because to import the palm oil from Asian country to Europe. So further studies need to be done on that part. And the next is the capital cost, depreciation, and the labor cost. So normally these labor costs couldn't be manipulate much, but we can do some manipulation on the government legalization. And the last one is yield and the quality of the product, where the current car producer, they are producing car with the compatibility with biodiesel fuel. So if the product is in a good quality, which can make sure the car engine can be sustained for the long run, will increase the demand for biodiesel. So directly it will increase the production of biodiesel. So that's all. Next, I'll pass to Regina to conclude the discussion.
Okay, so for conclusions, our group has decided that biodiesel is a better choice as biofuel in terms of its energy production yield and also carbon dioxide emission rate. So also to compare soybean biodiesel with bioethanol, it has major advantages over the corn ethanol because it provides more usable energy than the fossil energy needed for its production, reduce GHGs more compared with diesel, reduce several major air pollutants, and also has minimal impact on human and environmental health through nitrogen, phosphorus, and pesticide release. So the only challenge that will be encountered by the producer is in terms of raw material costs and also the cost to bring in the technology from outside the country. government should play their role to reduce this cost by giving subsidy to the biodiesel industry, as well as to impose import duty exemptions for raw materials or components and machinery or equipment used directly in the manufacturing activities. This is also one way to support Go Green campaign, which is introduced in the country itself. So that's all from our group. Thank you.